Lesson 2, exercise 1. Yeah, the lesson 2 was a little longer, so that's the reason I distributed the exercise into two parts, exercise 1 and exercise 2. And now I want to discuss the answers for exercise 1. So let's get started. Before starting, in fact, let me summarize what exactly we're trying to achieve in this exercise and the lesson. We want to discuss the concepts of hub. What exactly is the hub? What type of connector it has? And then also give details about the workflow of the frame. Who initiates the unicast frame? Who initiates the broadcast frame? That is going to be done by the starting PC who wants to start sending data. Second thing is how does a hub react or act when it receives a unicast frame or it receives a broadcast frame. For a hub, it does not make a difference. Whatever frame it receives, it is going to flood it. Okay. Whether it is unicast frame or broadcast, no difference. It is simply going to flood it. Keep that in mind. The next thing is, again, now putting the hub in between. Once the hub has flooded the frame, whether it is unicast or broadcast, the recipient, whoever is receiving it, PC2, PC3, whoever it is, destined for the frame, whether it is a unicast frame or a broadcast frame, we will see how they are supposed to act or react. Okay, so let's get started. The first question is, a hub has dash and dash connectors, and the answer for this is multiple RJ45 female connectors. Okay, pretty simple. Second, the connectors on hub are called. In the industry, we comfortably use these terms interchangeably, right? Sometimes we call them ports, sometimes we call them interfaces. There's no hard fast rule about how they are called, what not, but definitely they are not called sockets or terminals, right? Sometimes somebody will tell you, can you connect this wire to this port? And somebody will ask you, can you connect it to this interface? So these are interchangeably used, loosely used terms. Okay. Question number 3. What does a hub do when it receives a frame? Logic is simple. It is a dumb device. It does not care what type of frame it is. It receives and it floods it. And do keep in mind, it does not flood it back onto the port from where it received it. And the other thing, it also does not send it to the port which is not connected. There is nothing connected on it. It doesn't do it. So let's look at the option. So option B is it makes a copy of the frame it received and sends a copy to all other ports. By other ports means other than on which the frame was received. So correct. In addition to this, I would also add, even though it's not in the answer or the options, right? It does not forward it or flood it on the port which has no connectivity, no cable is connected, nothing is connected. That means that port or interface is idle, okay, not being used. Moving on to question number 4. Definitely, hub is a stupid device, dumb device. It has no intelligence, it has no memory, it does not maintain any table, so it's a dumb device. Okay, moving on to question number 5, right? So this is given a topology. Here we are saying PC1 is connected to port 1, PC2 is connected to port 2, and PC3 is connected to port 3, and nothing is connected on port 4. So don't get confused by this, right? This is just showing that a wire is going from PC3 and connecting to port 3, okay? Nothing on that. So the first question, if PC1 wants to send data to PC2, so intention is PC1 wants to send it to one destination, so it has to be unicast frame. That means PC1 is going to create a frame, put its own address in the source field and put PC2's address in the destination field and send it across. So it creates a frame. What will the hub do when it receives the frame? Hub doesn't care, right? It is a dumb device. Whenever it receives, it will simply flood it. So here are the details. It will send a copy of the frame out of port P2 and P3, correct? P2 and P3, it will send it out. Okay. It will not send a copy of the frame out of P4 because nothing is connected. I just explained this a minute ago. Okay, so it will not send it on port P4. It will not send a copy of the frame out out of port P1 because frame was received on it. Very true. So all the three options are correct. A, B, C are correct, and that is the reason the best option is all of the above. Right? Okay. Moving on to the question number 6. Same topology, everything is perfect. Same thing, nothing is different. Now the focus is changing from when the hub is sending it out, flooding that frame. What is expected behavior? What will the frame look like when it is going out of the port P2? What will the frame look like when it is going out of port P3? No magic here, nothing special. There is not going to be any difference, right? As I mentioned, the hub blindly copies, makes a copy of the incoming frame and floods it. So the outgoing frame, whether it is going out of port P2 or it is going out of port P3, is going to be identical. There is not going to be any difference. So that's why you can say, comfortably say, DA is going to be B on both the sides. Okay. So answer is DA for frame going out of port P2 will be B, and DA of frame going out of port P3 will be B. So these are the two answers. Okay. Don't get confused. It is not going to be C for going out of P3. It's not going to be C. Okay. Same topology again. Question is now the focus shifts from the hub towards the PCs. Hub has done its work, right? It has flooded the frame. Now the question is shifting towards PC. In this case, PC3. What is the PC3 supposed to do when it receives the frame? Look at the destination, right? We have clear about it that when a PC receives a frame, it does what? It looks at the destination address field, and the next step is check whether it matches with its own MAC address. In this case, it is not matching. The received value is B and its own value is C. So B is not equal to C. That's why logic says it should drop it, and it will drop it. It will drop or discard is the same thing. It will discard the frame as the value of DA field does not match its own address. Okay, done. Same topology again, but now the question is asked from the reference of PC2. Okay, as you can see, I'll pause here a second and from the question and see. So what we have done, we have understood when we initially did was PC1 to PC2 communication. How is it happening? Now just adding the hub in between, and basically the concept remains same. Receiving side, check the DA and check whether it matches or not. So, okay, going back after the pause to question number 8, how is PC2 supposed to handle the incoming frame? Again, it will check the DA value, it is B, compares it with own MAC address B, it matches, so it will accept it. So the answer is the correct option here. Okay, now which of the following are true related to properties of hub? Select 2. Okay, here the thing is, remember you have to apply the logic that what is the hub doing, right? Being a dumb device, it is wasting others' bandwidth. Bandwidth means whatever is the wire, right? Whatever it is sending out of the wire, if it is not required to send, and it's still sending it, that means it is wasting the bandwidth. Okay, the capacity of a wire in a way is called bandwidth, right? It is wasting the bandwidth. Second thing is any device for which the frame is not intended, right? In this case, PC3, it is not intended for that, right? In the previous example, topology, PC3, every frame it is receiving with the destination address of B, right? It is not matching with it, and it is to, but still it is supposed to spend CPU to check the DA value. Oh, it's matching, it does not match, drop it. Another frame comes in with the DA value of B, again PC3 will drop it. So every time it is receiving that frame, unnecessarily it is wasting its CPU. Okay, so answers are B and D in this case. Okay, going on to the question 10. What will you infer, what will you understand from the following two examples, right? So if you look at this, example 1, PC1 is trying to send a unicast because the destination address is not all, just for one PC. In this case, it is trying to send it to B. Okay, and in the example 2, the destination address set in the frame here is all. So PC1 in example 1 is trying to send it to PCB. In example 2, it is trying to send it to everyone. Okay. Alright, so So what is supposed to happen in here, right? So ideally what is supposed to happen in this case is PC2 should accept in example 1 and PC3 should reject it or drop it, right, in example 1. In example 2, PC2 should accept it and PC3 should also accept it. So that's the case. So for broadcast part, both should accept it. And from the hub's point of view, it does not matter. It should flood whether it is a unicast frame or broadcast frame. So okay, by the way, let's look at what example. In the example 2, as the value of DA is set to all, it indicates PC1 wants to send the data to all the PCs. I already explained that. In PC1, as the value of DA is set to B, it indicates clear, right? Simple. PC1 wants to send data only to PC that has address of B, which is PC2. Okay. So these are the answers. Sorry for the typo. Here it should have been option B. My bad. Apologies for this typo. Typing mistake. Let's move on. Same example. Now we have spoken about what is PC1 intention. Intention was unicast and broadcast. Right? Now the question is what will the hub do with it? Same thing again, right? It does not care. It has received a unicast frame, flood it, received a broadcast frame, flood it. So in both the cases, it is supposed to do what? It is supposed to basically, it's a dumb device, right? Whatever it will do, hub will blindly make copies of the incoming frame, whether unicast or broadcast, send it out of port P2 and P3. That's what it is, okay? So what is the key difference between a unicast frame and a broadcast frame? A unicast frame is intended for one and broadcast frame is intended for everyone, right? So that's what it is. The answer A is correct. Okay. Moving on to question number 13. Given the below two examples, what will PC2 and PC3 do when receiving the frame? I already explained this, but let's again look at it. In this case, PC2 will receive it and accept it because the MAC address matches. In this case, example 1, PC3 will receive it, check the MAC address, it does not match, it will drop it. In example 2, both will receive and accept it because the destination address is all and all PC2 belongs to all and PC3 also is part of all. So in both example 1 and example 2, PC2 will accept the frame and in example 1, PC3 will discard because it was intended for PC2, not for PC3. MAC address of arriving frame that the PC3 received was B and not C. Okay, that's the reason. Okay. Oh, this is a wonderful question and hopefully you are able to get it because majority of people, even with experience of 5, 7 or 10 years, even senior people make this blunder. They confuse flooding with broadcasting. Okay, so let's look at this. Question 14. Which of the following are correct network operations and why? Okay, network operation of the hub. If you can see here, the PC is sending a destination DA of B. As I mentioned few minutes back in some other earlier questions, hub does not modify any part of the frame. Okay, whatever it is receiving, it is going to make copies and send it. So is this doing that? Correct, right? It is in the example 1. It is not modifying anything. It is received a unicast frame. It is flooding the unicast frame. In example 2, see, it is sending a unicast frame again. But here, what is shown is the hub is flooding the frame. But while flooding the frame, the destination address has been modified from B to all, which is incorrect. Okay. So this is the incorrect option. This is incorrect. Okay. In third example, the destination address has been set to all by the initiating PC1 who wants to send the data. And here again hub has made a flood, made copies and sent it to both the sides. But while doing it, it has not modified the destination address. So this is also correct. Okay. So what individuals in the industry who do not understand the concept, who do not understand the deep concept, they confuse flooding with broadcasting. Okay. Flooding doesn't mean broadcasting really. Okay. A hub can flood a unicast frame. A hub can flood a broadcast frame. But a hub will not broadcast a unicast frame. let me repeat, a hub will not broadcast a unicast frame. In this case, a unicast frame was received, and here it is showing as if hub is broadcast, changing the destination address to all and flooding it. It will not do that. Okay. I think that's about it. That wraps up all the questions in the exercise number 1 for lesson 2. Hopefully you've got a good hang of it, good understanding of this concept, and we can close this session now and then reconvene for the lesson 2, exercise 2 in a bit.